Oh. So and then we have one. This one. Would this one be the B? I don't even have it.
When you're graphing these, be sure you identify amplitude, phase, all those other components for me, if you haven't already. Oh, we're making artwork on the wall.
But I'll put it
Which one of these would be the defect 2 minus 3? No, I don't know it. Which one of these? I don't understand. Like, which one of these? Like, mine like 2 minus 3, but this would be A, right?
Yes.
So then what about B?
That's in like a non-standard form, I think.
So how would you
Like
convert
this
it?
is, you don't worry about numbers. This is C, I believe.
But there's no such thing as.
I'm sorry, this is actually your vertical shift.
Oh, so the.
So instead of it being at the end, I think it's. I think.
then she dips out.
And the period would be 0 to 2 pi, right? Since there is nothing that.
Yeah. Yes, so your B is. Your B is actually. Oh, yeah.
So A is 3, right?
No, yeah. B is 1.
How many periods are we?
1, 2. A is 3. That's 3.
Okay, then the negative 3 flip, right? Okay.
Sam is a man that does his own follows. He so chooses.
Flip in the
I could
period.
try and slip some ink back into.
That's right, your homework. All right, I'm just saying. No.
Isaiah, I don't mean this. We're just speaking.
Speaking, got it.
Is that an extra marker? Yeah, all right.
Dude, I'm on 4 hours of sleep. Cry about it. This is the only thing I can do to keep my mind. at ease.
Explanation?
The tangent's the one that has the tangent.
Amplitude would be 3, so would we go up to 5? So if the amplitude is 3, and we have a vertical shift of +2, we go up to 5, right?
Except for me.
So we have an amplitude of 3, right? So if we had the vertical shift, would that make that go up to 5? So do it on to us? Okay.
Because, yeah, that's what you're doing. You're taking the origin, you're applying vertical shift +2.
Yeah.
And you're going 3
Did
above
you
that.
find your
That's
best?
+2. You're new.
I'm not, okay. Okay.
Oh. I thought you were on that one.
Sign starts on the bottom.
It starts with origin. So like
Wherever.
like normally it would start here. But it would go up.
Two. Yeah, that's good.
This is 0, 1, 4, 2, 4. That'll, everything else? Yeah.
Why did it? That?
You get your calculator.
He did it. I was trying to make it for. I was trying to make it for.
Now we got different. This is base. So it should.
Writing.
It's all right.
That's my first email.
Sandy boy.
Yeah, that's like 7.
Well, you divide by feet.
Song?
You divide by feet, okay?
Okay.
Okay, so you have your, but you did take the vertical shift up there, and you have, so if the vertical shift is here at 2,
Yeah, so.
so then 1, 3, and then 1, 2, 3. Yeah, but you just.
I didn't, I forgot about that.
Okay, and then the period, let me just check that really fast, between 0 and 2 pi, yeah, that looks right. You're looking, that's good, all right. Yeah. Math fraction, so you can take that answer
Amplitude is negative.
and then hit math,
Yes.
math is underneath alpha, and then just hit, it defaults to fraction, hit enter. Yeah. Well, what do we, because you have pi in there, so we can't change that. So if we want to do fractions on the calculator with pi out and just let it do what I call the grunt work, put pi back in, right? Okay, what are we looking at? That one? So if I have 0 here and then down to 5, I think, and then I'm up here at 1.
I'm at -2, yeah,
So
it's
you're
-5.
gonna- So make sure you label those from your
Okay.
test and then label this one up here or
That's-
wherever you're.
Yeah.
Yeah, but that looks good.
So,
When you think you've got it, you're ready to move on, that's fine. You can always check it on your calculator too. Coming around and trying to look at them all.
Just erase it.
Yeah, just erase it.
Word.
When you're done.
I just even have to.
Okay. Second one is this one.
Two periods. I think that's.
Okay, so you've got this right. So you have the right shape, you've got the right numbers, and you start.
Oh.
Everything else is easy. Okay, that's why you
sorry
kind
for
of.
messing you up.
No, it's okay.
We know our upper limit.
You don't have to know the marker.
What I meant is that.
Maybe in the box. Look underneath, Sam, look under that, welcome to rummage through that cabinet.
Yeah, gee.
No. 2 pi over b, so you need to identify. B is 1, right? Yes. You're gonna subtract that.
Oh, yeah. New mark.
Oh, yeah. You know who else is watching.
Wait.
This should be not a 2 anymore.
Pi over B.
Pi over b.
Pi over B.
It was handed, yeah, fine.
So that is technically going here.
Lil B. Thank you, base guys.
2x
Now,
equals
cotangent.
the
Cotangent and tangent are the ones that have vertical asymptotes. So the equation for the vertical asymptote
I think it's theta.
is bx equals 0. Pi. We've already identified the d. Dx is 0, dx. Why?
Scale it again.
I said just put d in there.
I'm going to cry.
Hey, man, it's not just your dog. Yes.
Your razor?
Our racer.
Power Rangers.
Oh.
I'm doing
Yeah,
it.
there you go. All right, how are we doing? That?
Yeah.
Y'all looking at each other's shoulders?
Remember that car series of
Zero.
I mean, this is the. Right. Plastic.
I don't make
Now-
really weird. I do.
You gotta teach them young.
Yeah. I'm the only one from the bottom.
Oh, that's. I didn't think it could go.
Press key. Something like this.
Okay, hold on a second.
All right, I'll wait.
Gotcha.
Oh, you can recursive?
Yeah. I can't recursive.
Most people.
I learned it in,
So what's your right foot?
I can barely write my name. Yeah, it's ugly. I learned it, sort of like, because like, we didn't even do computer on my
So
name.
Second.
You're right.
Just saying, bro. Calm down, bro. Just saying. Gee, Get along with this
And here he is.
I agree with your absence of this information, right?
Is not a.
I'm a victim of physics.
Well, I meant like, is that what the formula is? What it is?
No, I think you have to.
And you just put B in. Yeah, that's all right.
That's right.
Yeah, so just like-
Yeah, you put B in.
All right, so you use this one.
I was making sure. I forgot. I didn't forget, I was behind.
So which one are you on?
Well, I was thinking of like graphing, secant. Or I'm graphing.
A would be one. Just look at later. B is two. Over two. 2x equals 0.
Yeah. But you basically have this, each one of these.
Yeah.
Yeah, the 2x equals
It's the side of that.
Well, it's like
Each intercept is the side.
Oh, I expect you're about to ask.
Yeah.
Yeah, that's what I was saying earlier.
That was correct. And then the other thing is communication.
So we're good.
Yeah.
Okay, try different.
Yeah, so it'd be 2x equals 0. For cotangent, and 2x equals. And then
So
you just
I was.
solve out for both of them. That'll be 0. And that's your asymptotes.
Get the vertical.
Vertical shift, that is the.
Or did you try to tell?
You see, I didn't actually count vertical shift. Like I said, I'm running on 4 hours. There is no vertical shift. I'm just stupid.
Then you graph the numbers right?
The word.
So this
Started
is.
when you flipped it, right?
Unless I wrote the problem wrong.
Mine's always gonna start at its.
Oh, no, you wrote it wrong.
Oh, I wrote it.
Right, but other than that.
That's where I got the.
All right, Javi, I'm sorry.
Oh.
All right, so you might just sign X, so it's fine now. That's this one right here, right?
Yeah, I had it wrong.
So you shifted.
Yeah.
Did we look at this?
It did, but remember I had it flipped, remember?
Yeah, you just need to, so you should have been over here at the, what you doing? Let's go on, try another one, okay? Yes, sir, I will. Okay. Is it number 7? All right, and then.
Oh, I totally messed it up. I wrote the everything, but I forgot to shift it.
Okay, that's a common mistake. Awesome. Okay, yes, sir.
You got any right?
Oh, yeah.
To go to.
But cotangent is bounded by
This.
0 and pi.
Not saying.
So these two things right here.
I don't like the phase shift, it's just too much.
Tangent is negative
Too much subtracting.
That's why when we do the graph, where it is that's how we
Come on,
would.
come on.
But other than that, you got, if you had a flip. you could do it. Yeah.
Space it one more. Oh.
Okay? How we all do? I think you've got. And. Oh, I had a.
That's fine, but
You have 0 and 5. Add phase shift to the asymptote. So if this is changed, you shifted it up by 3.
that's where I
Right?
went wrong.
Not your big one, you get to mess up with. But you use the right numbers.
A little too much math.
Okay, all right, do one more. Armando, what have we got? Find me your best one.
You're supposed to go over.
2 minus 3x, right?
Yeah, yeah, yeah.
Minus 3x. So start down here at. Okay, so. Let's look at the numbers.
Pi is bigger than 500.
What would I do?
I don't know.
Okay.
Yeah, I want to.
No.
Oh,
I thought he was in trouble.
This is bigger. This needs to be right here.
Yeah, but
This
this.
is bigger than 5, it's 3 of them. Smaller than 5.
More negative.
What was the outside one again?
You don't take that one. Let's do that one. All right, let's do that one. Is that what I said? So I just use start at 3 pi over 2. Right? And then we have 2 pi, 5 pi. Oh, okay. 7 pi over 2, that's good. And then you go up to 3 and you look down to 3, and then we're good. Okay? Yeah, good. Tell me what you want me to look at.
This one.
I don't care. I can use my thumb.
I can't use my thumb.
You have a big.
Use your palm.
So let's just look at it. You have 3 halves, which is your amplitude.
Not other
You
palm.
have,
Sorry.
Welcome to college.
divided by 2, 5 over 4, yeah, 5 over 4 here. So you have b, which is 2. So your area would be 2 pi over 2 pi. You have phase shift with this, 0 to pi. Subtracting. That subtraction is right. It is. Yes. That's right. Rising, you don't have a vertical shift. So yes.
And when it's in the front like this, is a vertical shift up.
It doesn't matter if you just need to look here. 2 is the vertical shift, right? So is 2 positive or negative?
It's been positive.
So then it's a vertical shift up. The negative sign here is telling you that the function is.
So is this true with the-
Yeah, mine's gonna be the same.
Oh,
You
yeah.
have to use the sign after all of it.
It's a thought.
You would lead on that y equals -1 minus cotangent to x. The negative and the 1 are connected so that you know whether it's a shift.
So weird.
Upward.
My
It's understood to be positive, right?
Well, I understand that, like, that's positive, I was just saying that it's like that. vertical shift, But that's also vertical shift. The
Yes,
placement doesn't matter.
correct, because you are adding outside of the function. This is the function, right? The whole thing is a function, and I'm doing something outside of the function, as opposed to this, which is inside the function. Okay?
I understand.
What are you stuck on? Any-
I'm confused.
Uh-huh.
I don't know if I did this right. The first one.
So.
Zero prime, three pi.
That's
I know that's
correct.
big.
We only are interested in those numbers right there. We could care less about.
Yeah, that's good.
We only have to put that as the left asymptote, that as the right asymptote. and use it. Fine.
I will do that.
We don't need those.
Okay.
I need these three, left, middle, right. Draw your asymptote and then, but you should.
Plus three has the game.
Don't forget to double shift.
How do I do that? I did it on the back one.
So go down to one and then draw a temporary.
I was shooting.
So this is your left asymptote.
You did this
This is
one,
your right
right?
asymptote.
Yeah. Are these values?
Is this fashion?
Yeah. Okay.
So you come up and you cross here.
But negative one, so it's a flip. So it goes down.
Okay, so cotangent normally goes down,
Okay.
so this is gonna come up. And then cross there.
They do.
This too.
Yeah.
That's not quite right.
All right, finish up which one you're working on.
Reduce two of the one.
Yeah.
I guess.
Yeah, so, oh, yeah. Okay, so the calculator did do its job. Based in policy. That looks good enough. Did I do the finish? Okay. I did. Yeah.
Yes. I think I said that out loud. I'm sorry.
I know.
Oh, man.
We're only.
Well, this isn't a oh man, what
Yeah.
Yeah.
Okay.
Darn. I always. My sign wave looks very good. Stretching that big threads. Want it? Or we can have two.
That out of left.
You feel.
Yeah.
Yeah, right. I think I feel. Yeah, you're always thinking about your, you're so selfish.
You know what? I didn't do it.
You know what? I'm so sick of our mother as well.
I mean, technically. So that's supposed to add to the negative, but it ends up being the same. I get it starts. Yeah, so it's starting here.
You're starting to your Bible students.
See, that's why I messed up with the start.
All right. Practice, right? So you can check your work using your calculator. If you want me to come around and see it, I'll come around and see it again. Those of you that did it on paper, right? This is like your artwork. You can take it home and put it on the refrigerator and show everybody exactly what you're doing in class. Okay? Yeah, hey, it's refrigerator artwork, I think, for some people, but whatever, throw it away. What I do is
Yeah.
We kept doing certain
Yeah.
I'm looking for the term.
Yeah, you were.
okay, practice, right?
Well, I don't have that on research.
Use your hand. I want to use my.
Gotcha, Bo.
No, you know what, man?
So.
What? I spent 4 hours online. Yeah, no, I started like, cause I have like a period from 9:30 and 11, I don't have class. Yeah. I
Okay.
thought that was enough time.
That's what I did.
You know what, Marno? Everybody support me here, okay?
I'm
So how come you started? So you started down
Because when you answer 2, 3.
Amplitude is 3, but this is
Oh, wait.
sine, right?
Oh, yeah.
So sine has to
Oblique
start
is like
here.
the flat one and the add line.
And then
And
go
isometric
here,
is like 30 degree.
and then cross.
And it
has
has
to
like
go up.
45
Okay, so just erase it. All right, so are we feeling a little bit better about some of the graphing,
Honestly, yeah.
right? We need to practice that.
Isometric too. So it's like.
So if you didn't get to all of those problems, right? If you didn't get to all of those problems, take a picture of it over there. Practice it. Come by and check with me. We'll check with the calculator, right? To see if you got it right. And I would be happy to go over it with you if you're having any problems with it. So the next thing that I kind of want to talk about. So as I'm getting this set up here, y'all remind me, what's the period for, which functions have a period of 2 pi over b? Yeah, I heard all that. Try it one more time. Sine, cosine,
Cosecant.
and cosecant, that's right. So therefore, which functions have a period of pi over b? Tangent and cotangent. And how do I find the asymptotes for tangent?
dx equals negative pi over 2.
Yeah,
So-
0, and the x equals
That's for code.
Which one did I say? Tangent? I said tangent, I had to check with what I was thinking, right? Tangent is negative and positive pi over 2, right? Tangent is centered at the origin, bounded on the left and right by negative pi over 2 and pi over 2. Cotangent is the one that's shifted to the right. It is bounded by 0 and pi, okay? And of course it repeats, but those are the two that I focus in on so that I try to remember what the equations are because they change. So just like sine and cosine are separated by basically a phase shift, tangent and cotangent are separated by a phase shift as well. Okay, so they've got different formulas for it. Okay, so let's look at this problem. Oh, I need to, okay. Let's look at this problem right here. And then I've got another activity for y'all to do, so don't get comfortable, all right? If I wanted to, glad you're here today, right? So I saved this, we'll pretend that I saved it for when you were back, okay? This is moving the position of an arm. It shows the diagram of a rhythmically moving arm. The upper arm rotates back and forth from the joint, measured by the angle between the position and the downward vertical position. So you can see what they're talking about here, okay? And they were able to take that information and graph it. So this is the graph represented by the problem that we're looking at the top. Okay, now, my challenge to you is going to be, how can we figure out if we are told that we want to find out the form of this equation in terms of sine. Okay, so I'm telling you I want an equation for in terms of sine. And I want to, out of that equation, I want to be able to figure out what is the amplitude. And I want to be able, or not out of that equation, out of the graph, I want to figure out what is the amplitude and I want to figure out what is the period. Take just a second. Think about that for a second. Okay, so all I'm looking for here is I need you to figure out, based on the graph of their description, what would the amplitude be and what would the period be? Okay, and write it down on your paper, what you think you've got it. Okay, you think you got it? Yeah. What do we think the amplitude would be?
1/3.
Everybody agree that the amplitude would be 1/3? Okay, that one's fairly straightforward. Amplitude would be 1/3. What do we think the period would be?
0 to 3/2.
Okay. And so therefore, if I know that the period is 3/2, okay, how do I figure out what B is in order to put it into my equation? Or in this case, how do I figure out what K is according to their equation right here?
But 3/2/B.
Okay. I would say that that's a good start.
I mean,
Right. Trying to get my pen to work. So if we all said that the period is 3/2, everybody was able to concur with that one. And I also know that we defined the period as 2 pi over b, correct?
Make that equal. Okay.
So if I make 3/2 equal to 2 pi over b, I can just set it up as an algebra problem for the most part to be able to solve for b or k, right, in this case. All right, so one way would be to cross multiply. I would get 3b is equal to 4 pi, or in other words, b would be equal to 4 pi over 3, correct? 3b, if I cross multiply, is equal to 4 pi. And so then I could come up with the equation that looked like y is equal to 1/3 sine of 4 pi over 3 times t as the function for the graph that we see right there. You have some problems that are similar to that on your Desmos activity, where you are being asked to find that equation strictly from the graph. What you want to do is you want to locate the period. You want to identify what the period would be to be able to solve for b. Does everybody understand how I got this b right here? Yeah, I just used the definition that we were already given for the period, correct? Yeah. Okay, so there are some problems in Desmos that I want you to keep working on. I believe I said that those were due Friday, right? You haven't already finished them. And so yeah, keep working on those, keep practicing on those. We'll practice the rest of this classwork when we get to class. Maybe tomorrow, if we have time, but I'm ready to move on, and we're going to talk now about inverse functions. Okay. So again, if you're getting stuck on some of these, by all means, come and meet with me. And we're going to talk about inverse functions. I always like studying the application of inverse functions. Or I think that they're fairly interesting. You actually use inverse trig functions a lot. They have a whole lot of application. And one interesting application that I found, so when we're thinking about an inverse function, we actually know the value of the function, and I want to try to figure out what was the angle that gave me that value. So I'm going backwards when I think of inverse functions. All right, I'm trying to figure out what angle I had to be at in order to get a function value. Okay, so an application that you see all the time is if maybe I wanted to know what the height of a building was. So, right, I'm a math teacher. I come from a family of teachers. And so if you're my child, then you have to do crazy things like that over summer, like go figure out what the height of the Alico building is. Okay, and so we can do that by being able to know what the distance, so if I'm standing a particular distance away from the base of the building, and here's the Alico building here, and I'm able to estimate, let's say, through using technology, I'm able to estimate theta, right? Then technically what I'm looking for is the height. Why? Yes? I want to know what the height of the building is. Well, I can use trigonometry to be able to figure that out. I can actually use tangent to be able to figure it out. So in other words, I can use trigonometry and functions to be able to know what that is. Now, I guess inverse is what angle would give me, if I know what the function value is, I guess I should say, if I know what the function value is, what angle would give me that, let's say, elevation, if I was looking at it in terms of that. So another probably better example, now that I think about it, might be another one that I learned was blood splatter. So I told you my daughter is a forensic science major, so I would try to find some of these things. Blood splatter. So in a forensic crime scene. They might want to know what angle you were at. If they have the blood splatter, right, they're wanting to know what angle maybe the blood came from, is an application of inverse functions. Now, when we think about inverse functions, we first need to talk about, and I'm going to skip down here, I'm kind of come back to that, but I first want to talk about this. So if you were writing those definitions down, just hold off on it, I'm going to come back to them. If you remember from college algebra or from a previous course that we had the vertical line test. What did the vertical line test tell me?
If they grabs a function or not.
Right, so we had a vertical line test that told me if something was a function. And then we have another line test, which is called the horizontal line test, that acts in the same way to tell me if a function is 1-to-1. Okay, and so just like in the vertical line test, if the line touched the function in more than one place, we said it wasn't a function, right? So in a horizontal line test, if we have a horizontal line and it touches the function in more than one place, it is not considered 1-to-1. The reason this is important is because a function and its inverse are 1-to-1 functions. In other words, for a function to have an inverse, it has to be 1-to-1. Can you think of an example from a previous class, possibly a function that is 1-to-1? A cubic function is 1-to-1. A exponential function and its log partner, right? Exponents and logs are inverse functions of each other. An exponential function is 1-to-1. A log function is 1-to-1. They are inverses of each other, all right? And so when we think about inverse functions, although we may have a function like a parabola right here, which just, it's a function, but it's not 1-to-1. If I wanted to find an inverse for it, I can manipulate it by restricting portions of it. So if I now only want to look at this function on the interval between 0 and infinity, if I were to pass a horizontal line through that function, it would now pass the horizontal function, the line test, wouldn't it? It would now be considered a 1-to-1 function, okay? So when we are thinking about our, when we're thinking about our sine functions or any of our periodic functions, they keep repeating, right? They're just, especially sine and cosine, they're bouncing back and forth between the number 1. They go on forever. If I were to pass a line, a horizontal line through this sine function, would it be a 1-to-1 function? As it is right now, it would not be, correct? Okay, so how can I talk about inverse trig functions if the functions that we're looking at, the family of functions that we're looking at, are not 1-to-1? So we can manipulate it and restrict the portion that I want to see. And so what we're going to do is we're going to only look at the portion of the function for sine. We're only going to look at the portion of the function that falls between negative and positive pi over 2. Okay. And now if I restrict it to that blue part that you see up there, it passes the horizontal line test. It becomes 1-to-1, and therefore it will have an inverse. Okay, and one of the things that we get when we restrict the domain for the sine function like this is I'm going to restrict it to values of sine that are, I have one quadrant, I have only one option for positive values, which would be the first quadrant, and I would have one quadrant of negative values, which ends up being the fourth quadrant, right? Because pi over 2 and negative pi over 2 are going to travel in the first to the fourth quadrants. And I'll show you that again in just a second. All right. So what we're looking at then when we think about inverse functions is I have to restrict their domains. I have to restrict the function's domains in order to apply the property of inverse functions. Okay. Now, if you don't remember, The other part for inverse functions that, just as a reminder, because we cover this a little bit more in another couple of weeks as a refresher, that so if I'm thinking about a function who has both a domain and a range, the inverse of its function is flipped, right? That's kind of the idea anyway. We'll flip the y and the x, all right? So what we get for the inverse says, okay, the function, the inverse function is going to be the opposite as far as domain and range are concerned from what you started with. And I'll show you what that means in a minute. So you kind of want to, you'll be refreshed with that in just a second. All right, so I'm going to go back here. And that might help explain just a little bit of why we have these restrictions. So we're no longer talking about a sine, cosine, or tangent function who has infinite possibilities here. We've actually restricted them. What this says is, it says that for sine, we can say y is equal to the arc sine of x. Arc sine and inverse sine are interchangeable for us, okay? Y is equal to the arc sine of x if and only if sine y equals x. In other words, the sine of the function has to exist first, and then we can talk about its inverse, is all that says, okay? But we're now going to restrict the inverse function to only be the domain. So the input values now are going to be from negative to positive 1. And the output value, the angles that I'm looking for, that's what we find when we're finding inverses. The angles that I'm looking for are only going to be those angles that go between positive pi over 2 and negative pi over 2. So I'm only looking for those angles there, all right? We do the same thing, a similar process with both inverse cosine and inverse tangent. So we restrict the domain for cosine to be negative and positive 1. And we're only going to look for the angles that fall between 0 and pi. So again, we're getting that first quadrant positive angles for cosine and the second quadrant negative angles for cosine. Previously, anytime I've been trying to figure out, an angle for cosine, there's been 2 positive angles that I'm going to get, or 2 positive function values I get, and 2 negative, right? They repeat. So what we're looking at here when we think about inverse functions is we're going to restrict it, and we only have to worry about 2 quadrants, let's say, so 2 answers. And then you'll notice that tangent is going to have the same output angles between negative and positive pi over 2 as well. So those are what the graphs of our inverse functions look like. We don't actually graph these functions in here, okay? But you can see that we have restricted it. Now the y values fall, but what would have been the y values for sine, negative and positive 1, are now falling on the x-axis and the x-axis, so they are inverted from each other, is technically what an inverse does. We switch the x's and y's if we wanted to solve it. And we actually go into how we do that algebraically. So I'm going to build on this definition in just a minute, but let's take this idea and let's practice a couple of function values when we're just thinking of sine. So remember, what you're going to be asking yourself when we think about inverse functions are going to be, what angle, when I take the sine of it, is going to give me this value? What angle, when I take the sine of it, will give me this value? So we're just going to focus on sine. Now remember, I told you that sine, the inverse sine, is only going to have output angles that are going to fall between negative and positive and negative pi over 2. Okay, so only angles that fall in those quadrants there. So if we're trying to think about an angle that when I take the sine of it, let's look at number 1A here. if I'm thinking about an angle when I take the sine of it, it's gonna give me -1/2. I have to be in what quadrant? 4, because I've restricted this to only be options 1 and 4. So I'm down here. So what angle, when I take the sine of it, do I get -1/2? I use my hand a lot here. I'm gonna fold my finger down until I figure out 1/2 below the fold. What angle am I at? What am I at?
30,
Okay.
or negative.
So
11 pi over 6.
Okay, so I've got 30, I've got -30, correct, right? So I have this angle here, -30 degrees, or -pi/6 if I was only answering this in radian measure, right? Edward, you said 11 pi/6, correct? I'm glad you said that.
30 degrees.
Okay. The answer to this, and let's just keep it in radian measure, the answer to this is -pi/6. -pi/6. So although 11 pi/6 is coterminal with the one that we've said, we've restricted the angles that I'm looking at. I can only look at angles that are between -pi/2 and +pi/2. So 11 pi/6 is outside of my purview, right? It's outside of what I'm looking at. So it is not an answer. The actual answer would be -pi/6. Okay? That's the answer that we're looking at. Because we restricted it, I can only look at angles that are positive or negative. So I would have to rotate negatively here. Okay?
Why is it only quadrant 1 or 4?
Because that was how we collectively said we want to look at sine. We restricted sine. We said the range for sine, remember we can just go through and we could restrict it to whatever we wanted as long as I ended up with this sliver of graph that was 1 to 1. So everybody out there said, no, we're going to restrict it to only be angles that are falling between negative and +pi/2, which is quadrants 1 and 4.
Isn't the negative sign in quadrant 3 though?
It is. But can I look over there?
No, it's not confused how it goes over.
Okay.
More.
All right. So we have, let me go back here. We have angles here, which would be, what would that be, 7 pi/6. This angle here, which we already said was 11 pi/6, correct? Okay, but the angles, the only angles I'm allowed to look for are angles that are going to be between -pi/2 and +pi/2. Okay, these are outside of those angles. They're larger than pi/2, right?
Yeah.
Because they're bigger, their numbers are bigger, correct? Okay, so I can't use those angles. Those angles do give me a -1/2, but that's not in the range. It's not in the allowable range that I'm looking at. When I ask for the arc sine or the inverse sine of -1/2, you're only allowed to give me angles that fall between +pi/2 and -pi/2. So in other words, I'm going to have to rotate negatively to be at -pi/6.
Okay, that makes sense.
I used to say you can't, so the only zone that I'm looking at here, these are the 2 quadrants I can look at, period. And you can't rotate out of the zone and get back in. That's not allowed. Okay, you have to stay in the zone, if that helps. All right. How about this one? We've got inverse sine, so we're just sticking with sine right now. All right, so we have inverse sine. Notice the 2 notations that I put up there. One says arc sine and one says inverse sine. All right, they're interchangeable. And I want to know what angle, when I take the sine of it, do I get a positive value? Well, what quadrants would that normally put me in?
What did it put you in 1?
It would put me in 1 and 2 normally, but I've restricted my answers to only be an angle in quadrant 1, right? Those are the only angles that I am allowed to now
So
look at.
is that this period whenever you apply the
Inverse,
inverse.
yes.
Makes sense.
Right? So if I wanted to know what angle, when I take the square, when I take the sine of it, do I get the square root of 3/2? What value would that be at? Pi over 3. Right? This angle would be pi over 3. Because that's when the y is. Say that again? Yes, when the y is square root of 3/2. So this would be pi over 3. Pi over 3. Okay. So how about the inverse sine of 2?
So.
I'm trying to trick you here.
But that'd be 2 rotations around.
There's not one, right? Because we restricted our domain even, right?
Oh.
We even restricted the domain to only be values that are, so the input values that I can look at are only going to be numbers that are between -1 and 1. Sine bounced and forth between -1 and 1, so those become the input values for the inverse. 2 is outside, is not within that, and therefore it does not exist.
So is it like undefined basically?
Undefined, does not exist. You can write does not exist. All right, so if you tried to do, get your calculator out, try to do the inverse sine of 2.
Yeah, errors.
You get an error, right? Doesn't exist. Do the inverse sine of -1/2. When you get a negative number. Yeah,
Yes.
because that's that negative angle rotation, right? Okay, so your calculator is going to keep giving you back. It knows already, right? It's been programmed to give you back those values that already have the restriction. We're going to practice this again. We focused on sine. So if you want to take a picture of this, that's great. If you want to write it down really fast, I believe it was in the notes that I posted. Riley, is it in the notes that I posted? That image? Yes. Okay. So you can always go back to the computer and get the notes.
Or in the notes?
Yeah, it's in the notes. So this is a more succinct way of identifying what I was just talking about. So you see all 6 trig functions, all 6 inverse functions on the left over there, along with their domains and their range. And the last column is just simply telling you what quadrant we would be looking at. What zone do I have to stay in? Okay. All right. Let's think about this idea here before we go on and practice this a little bit more, okay? So we want to consider the inverse cosine function, which we define as y is equal to the inverse cosine. So that to the -1 is an inverse. It's not a reciprocal. It's an inverse, all right? Or we can define it as arc cosine. Okay. And when we're looking at this, the question that I want to ask you, or not all those questions, but I want to focus on this one down here. Okay. And we're looking at this and we go, okay, so if I know that arc cosine -1/2 is equal to 2 pi over 3. Why is that also not equal to -4 pi over 3? Somebody can't, right? It's not in the zone, right? I feel like an AutoZone commercial, right? 2 pi over 3. 2 pi over 3 is over here, correct? We define cosine, the inverse cosine, to only be valid for angles that fall up here in quadrants 1 and 2. But if I rotate -4 pi over 3, although I am coterminal with the rotation, I am outside of my range, right? I am not allowed to do that, for lack of a better word, okay? That is not valid, okay? So although they were coterminal, you can't really do that so much in this. Let's practice some more of these. These are really just practice ones. Yes, sir.
So if you said that the inverse of sine is only restricted in the first quadrant, how is? 'Cause
First
on-
and fourth.
Oh, okay.
First and fourth. So when I restrict these, I at least get a positive answer or a positive value for my function, and I'm gonna get a negative value for my
So
function.
then, how did the two not exist? If-
That was in the domain. So this column right here are the possible values that I can input, right?
Oh,
Yeah, so it's, I know, we're kind of mixing domain and ranges here. All right, let's practice some more of these. Let's start with B first. So remember, you're asking yourself, what angle do I have to use? What angle is going to give me? What am I looking for? Right? What angle, when I take the cosine of it, do I get the square root of 3/2? Okay, so did y'all write that problem down? Okay, so if I'm looking at the square root of 3/2, the only angles, which is the output, right? That's the range. The only angles I'm allowed to look for are angles that are occurring in the first and the second quadrant. So what quadrant would I be in then for a positive cosine? I'd be in the first quadrant. So what angle, when I take the cosine of it, do I get the square root of 3/2? 30 degrees or pi/6, right? Okay. You see that's just when cosine's positive. All right, let's look at the inverse sine of 0. So for sine, I can only look for angles, for inverse sine, excuse me, I can only look for angles that fall between negative and positive pi/2. What angle, when I take the sine of it, do I get a 0? That's got to be a quadrantal angle, right? It's got to be a quadrantal angle. So I have 1, 0, 0, 1, and 0, -1. So what angle am I at?
0.
0, right? Okay, you do letter D. Y'all do letter D. Can you show that letter D? If you got it? Yeah? So cosine, we said we restricted to these angles here, to those quadrants there. What quadrant would I have to be in then for cosine to be negative? All right, and what angle then would I have to be at?
135.
3 pi/4 or 135. All right. Now, you either have these memorized or you have some other trick that you're using, right? Okay, you either have them memorized or you're using some other trick. Now, when you have this here, the tangent, I'm going to look at that. So my personal preference is I'm looking at that and I'm going to say that's the same thing as the inverse tangent of -1 over the square root of 3. All right, correct? I'm going to put it back in a different form because that's how I use my hand. Okay. So if we have tangent, we've said that tangent angles can only be those that are here between the first in 1 and 4. For tangent to be negative, what quadrant would I have to be in?
4.
Yep. 4. what angle, when I take the tangent of it, do I get 1 over the square root of 3? I'm gonna fold my finger down until I get sine below the fold, which is 1, square root of 3 above the fold. What angle is that at? Pi over 6 or 30 degrees. Okay, and so it's negative, so this has to be negative pi over 6, correct? See what we're doing here? We're going backwards. We're trying to figure out what the angle is that gave me the function value that we're talking about. Okay. Let's do these two. These are a little bit more challenging because these would be, they're just more challenging. When I look at letter E, when I think about cosecant, okay, I'm actually going to think of this in terms of the reciprocal. So I know that when I take the inverse sine of some angle, I'm going to get 1 over the square root of 2, right? Because that's just the reciprocal of the answer, correct? That's our definition. So sine was restricted to the first and the fourth quadrants, but we're positive here when I took the function, so positive sine, so I have to be in the first quadrant here. So what angle, when I take the sine of it, do I get 1 over the square root of 2? If you have the other memorized, that's fine. This is just the route that I usually go.
45?
45, right? It's always a square, it's always 1 over square root of 2. Yeah, or square root of 2 over 2. Right? So this would be 45 degrees or pi over 4. And it's the same angle, right? That angle, 45 degrees, gives me cosecant. The cosecant of 45 is the square root of 2. The sine of 45 is 1/2, 1 over the square root of 2, right? So that is the same angle to answer that question. See if you can come up with the angle for inverse cotangent of negative square root of 3 over 3. And by the way, I'm just going to go back really fast to remind you up here, what were we doing cotangent? Notice that, and you wouldn't know this till I pointed it out to you, cotangent can only be in quadrants 1 and 3, okay?
1 and 2?
1 and 2, I meant to say, yes, thank you, 1 and 2. We're restricting cotangent to 1 and 2.
Wait, I mean 5 pi over 6?
So if we restrict it to 1 and 2, we're over here in the second quadrant because cotangent's negative, right? This is the same thing as cotangent of 1 over the square root of 3, right? We undid it a little bit. So what angle would I have to be at in the second quadrant?
120?
2 pi over 3, 120. Okay. Those are not as easy. Cotangent, cosecant, and secant are usually not as easy because we've always thought of them as the reciprocal, but it's kind of like an undoing of it. Okay, and we can practice this some more later.
So how did you get the negative 1 over square root?
I unradicalized it, rationalized it.
Okay, and then how are you getting the 2 pi over 3 and the 120? Because like with the other one, it makes sense because of like the cosine and the sine being like the x and y of the points on like the unit circle, but
But what am I doing to figure it out?
Yeah, just because 1/3 isn't.
Right,
I just-
right.
Where you finding out that it's 2 pi/3.
So you either have it memorized, and I'll let anybody else join in on this if you want. So there's many ways for you to handle this part, right? You either have all of these numbers memorized, okay, or are familiar with them, or I happen to use my hand trick to go in this direction. So I'm going to try to figure out what angle when I take, so what angle is going to give me 1/√3. So my fingers folding it down give me those values, right? So I'm going to fold my finger down to where cotangent, right? Cotangent. So cotangent's above the fold. So cotangent is cosine over sine, I should say. Cosine over sine. And I folded it down so I have a 1 in the numerator and I have a √3 in the denominator, which is why I unrationalized it right there. And that tells me that that it is at this. Yes. Okay. Other ways that you're thinking of it? How else are y'all thinking of it? Anybody want to share a different way that you're using? Not yet? Okay. All right. So inverse functions, that's going backwards, right? Now you can use your calculators. They're fairly straightforward when you've got the buttons, sine, cosine, and tangent. So if I were to find the tangent of 0.4, I'm assuming I'm in radian measure here, by the way. I think I'm in radian measure. So that would be the mode that I need to be in. So I'll take the inverse tangent of -0.4, and what do you get? All right, -0.38. Everybody able to find that when you're in radian mode? What do you think we're going to do for inverse secant?
1/the inverse cosine.
Sort of. I'm going to use the inverse cosine, and then I'm going to take the reciprocal of the angle, or I mean the reciprocal of the function. So this is where they're different, right? One is 1/, and this is a different area. And what do we get when we do that? 1.23. I just have to write them down and practice them because I don't know. I don't use them enough to always remember them forever. So just practice them. So those are kind of the special things you have to do in order to use your calculator. Now, let's talk about composite functions. Okay, so composite functions are when I take a function and I compose it with its inverse. That's what we're talking about here. When I take a function and I compose it with its inverse, they're basically undoing each other, is what's happening. And so if I have a function that I've composed with its inverse of some value x, I get x, and vice versa, okay? So the reason we want to think about this and understand this property is because when we start solving trig equations, that's technically what we're doing, is taking the inverse of each other of the sides, all right, or both sides of the function. So this is why we go through this process of kind of studying it. Now, the tricky part when we're looking at this has to do with when I evaluate a function and its composition, in this case right here, okay? When I evaluate a function, I normally am not that particular. I'm not normally caring about domains and ranges that much, but because we've gone through and we have done all of this work to the inverse function, right? We have adjusted and we're kind of talking about their domains and ranges. Then we have to make sure that we focus on the domain and the range of the inverse portion of this composition. That's the one that throws a kink in everything, okay? Is the domain and range of the inverse function. So let's just look at this first example here. It says I'm going to take the tangent of the inverse tangent of 45. And if it follows the rule above, if I take a function and its inverse and compose them, I should get the number 45. That's the goal here. But we have to make sure that the inverse tangent, right, exists, or that the domain in this case of the inverse tangent exists. So can I even perform the inverse tangent of 45? And I can, can't I? Because our domain for this was positive and negative infinity, right? We'll go back and look. So because this portion checks out, we can then compose it with the other portion, the tangent, and we would find that the answer is 45. All right? So that's the only caveat when you're doing this, is you have to check whether or not the inverse portion, the domain and the range are valid. Let's look at this next one over here. I've got the sine of the inverse sine of negative 0.2. It's the inverse guy that we're concerned with, and is a negative 0.2 valid? Is that a valid input number for inverse sine? Yeah, because inverse sine has a domain from negative 1 to positive 1, correct? And this number fell between there. So therefore that checks out. And so we would just say the answer is 0.2. And this next one is a little bit more involved. Yes, ma'am?
Why wouldn't it be negative?
It would be. It's the same thing. Okay. This next one is a little bit more involved. For this next one, we're looking at the cosine of, so when we do composition functions, if you don't remember, you always work from the inside out. That's typically how we work them. And if I wanted to talk about the cosine of negative 3 pi over 2, that's okay, we can do that, right? What's the cosine of negative 3 pi over 2? It would be what?
It'd be,
That would be over 0 up 1, correct?
yes, ma'am.
Okay, and so that is going to give me a value at, let's see how I can say that. So that is valid, right? That's a valid number that we have here. Now, the thing that we have to consider, however, is if the inside, so the inside checked out, okay, but now we're going back and we're saying, okay, this time, what are the possible angles that I'm allowed to have if we're talking about inverse cosine? I have to restrict the angles to only look at angles that are between 0 and pi, correct? Okay.
Yes, ma'am.
So the answer to this is not going to be, that it's not going to be negative 3 pi over 2. Instead, the answer to this would be positive pi over 2, right? Because pi over 2 is actually between this area right here. Does that make sense? So the only angles for if you're thinking about what angles when I take the cosine of it do I get? How about I put it that way? That'd be better. What angles when I take the cosine of it do I get? 0, right? The only angles I'm allowed to use would be those angles that occur here on this interval between 0 and pi, okay? And so that's why this answer right here is pi over 2 and not 3 pi over 2, all right? Practice those. That's all I've got to say is practice those a little bit more. And when you're practicing them, try to draw a picture. All right, let's look at a composition in a different way where I'm not composing a function with itself. I'm not composing a function with its same trig function, okay? I'm going to do a composition function still, only this time, if you'll notice these examples that are shown up here, we're composing they're not the same, right? We're not composing it with itself. So we've got the sine of the inverse tangent of 3/2. Okay, and we want to figure out what the exact value is of this function. So what we're going to do is I am going to take, because we already said that when I am doing composition functions, I work from the inside out, but I'm going to rewrite the inside of this using kind of what we've been talking about as far as what I would call the definition of our inverse functions. So I am going to let the inside here be equal to theta. So I'm going to say theta is going to be equal to that inside portion. I'm going to do a substitution in other words. Now, if I have this statement written right here that theta is equal to the inverse tangent of 3/2, then I am going to rewrite this as the tangent of some angle then must be equal to 3/2, right? Isn't that kind of what we're saying the definition of our functions are? The tangent of some angle is then equal to 3/2. Are we all right with that? Okay. So if I've done that, right, I'm saying tangent of some angle is equal to 3/2. And now we're going to go back and we're going to go all the way back to what we started doing last week at the beginning. What is our definition of tangent? It's defined in terms of x, y's, and r's as being what? Y over x, right? And so from this notation, I know that y has to be 3, x has to be 2, and therefore r has to be the square root of x squared plus y squared, or the square root of 13, correct? So if I came over here and I thought about that for a second, I've got this angle theta, and I know that the y value is 3, the x value is 2, and the r value is the square root of 13. So now, if we made the substitution at the beginning that said the sine of theta, right? We substituted for theta. We can say, okay, well, based on what we have defined theta to be, the definition of sine is what? Y over r. And so therefore, this would be 3 over the square root of 13, or 3 square roots of 13 over 13. All done by a substitution at the beginning. We substitute at the beginning to take this angle apart, so to speak, and then we use that information to figure out what the function value is. Let's try that again. Okay.
So 3 squared root 13 over 13 is the final.
So, yep. The sine of the inverse tangent of 3/2 is 3 square roots of 13 over 13. It's a composition work from the inside out. Let's try it again over here. So we're going to let the inside be theta, right? We're making that substitution. So in other words, if I let theta be equal to the inverse cosine of -5 over 13, then by our definition of inverse functions, the cosine of that angle, the cosine of some angle, has to be equal to -5 over 13. And this is where we're going to use what we just talked about. Where does the inverse cosine, what quadrants are we only allowed to have the inverse cosine in?
1 and 2.
1 and 2, right? So I know now that this has to be over here. That would make sense anyway, because r is always positive, but. Now, so it has to be over here. So by the definition of cosine, I know that X is -5. I know that R is equal to 13. And Y has to be equal to what? It's a special triangle. 5, 12, 13, right? So this has to be 12. If you don't know that, you can use Pythagorean theorem, okay? And I know that Y is positive because I know that I was restricted to being up there in those top 2 quadrants. Okay, so if I know X, Y, and R, then I can take the tangent of theta, which is going to be -12/5. They're much easier to do. These are much easier to do than the ones we were just doing.
Yes, ma'am.
The ones where you've got an inverse of itself is a little bit, that's a brain teaser, is really what that is. These, you have a pattern to follow. You let theta be equal to the inverse part of the inside, and then you use that to solve. Now, the last one that I want to work with you has to do with this one right here. And I would say that the directions in this is I want to be able to write this as an algebraic expression. All right. So if you notice, I've got a variable u in there, don't I? I don't have a number that represents the denominator. So we're going to come up with an expression with letters in it, basically, to be able to define this. Okay, and we're going to do it using the same method that we did before. We're going to still let the inside here, where the inverse is at, we're going to let that be equal to theta. And so therefore, sine theta must be equal to 1/u. And if I were to kind of sketch what's going on here, I am restricted to the first quadrant for positive values. I know this is going to be theta. And sine is defined as y/r, correct? So I would have y/r. And this horizontal position here, right? This x value here that we would have is going to be the square root of the radius squared minus the y squared part, right? U squared, square root of u squared minus 1. So that means this horizontal part would be the square root of u squared minus 1. So I'm asked to find what the cosecant of theta would look like. All that work. What's the cosecant of theta? U. U/1, which would be correct. It would make it, what if I said, what if instead of cosecant, it was secant? Right? What if I wanted to know what the secant of theta was? Secant is r/x, correct? So we would have u over the square root of u squared minus 1. That's also an algebraic expression right there. These should be our derivatives of our trig functions. That's what they're going to look like right there. Okay, look like that. So when you are asked on your homework or on your practice problems that you're all practicing to give an algebraic expression, that's what we mean when we give an algebraic expression. There's no real numerical answer, is there? It's just all a bunch of letters, okay? As opposed to up here where I actually got an exact value that I could look at. Okay, so we have to introduce inverse functions so that when we look at our equations after our test, when we start solving trig equations after our test, we use these to be able to figure those out. We used inverse functions to be able to come up with the answers to our trig equations. All right, so we have to be aware of how we find those answers. Okay? All right. Now, when we come back tomorrow, Isaiah, you have a question?
Yeah, on secant theta, right, equals u over this square root of x squared minus 1. Do we have to move that square root or no?
No.
No,
Remember in calculus, we get to,
leave it.
yeah, yes. You wouldn't, yeah.
Yeah.
No, you can just leave it. So when we come back on tomorrow, which is Thursday, we are going to finish this unit by going over applications of our trig functions, right? Application problems. We do a lot of classwork over those things tomorrow. And then understand that you have a test over all this material come Tuesday next week. All right? If you've got questions over what you're working on, please, by all means, come and meet with me. All right. I will talk with you later. Y'all have a good